Good afternoon, students. Welcome to your mathematics class. In this class, you will learn about the chapter The Triangle and its properties. Today I will discuss about the Pythagoras Theorem. Pythagoras was a famous Greek philosopher. He gave a wonderful relations between the lengths of the sides of a right triangle, which is generally known as the Pythagoras Theorem. So let us first know about the right triangle. We know that if one angle of a triangle is right angle, that is 90 degree, then it is called a right angle triangle or simply right triangle. Now look at this figure. Here this figure shows the right angle triangle with right angle at C. So here angle C is equals to 90 degree. Now the side opposite to the right angle C is AB, called the hypotenuse. So here AB is the side opposite to the right angle C, which is called AB is called the hypotenuse, and which is always the longest side of the right triangle. And the other two sides adjacent to the right angle. So here BC and AC are the two adjacent sides adjacent to the right angle, are called its legs or base and perpendicular. In other words, we can also say here side BC is adjacent to angle B, called the base, and side AC is opposite to angle B, is called the perpendicular of the triangle. All we know that a triangle has three medians and three altitudes. Let us know about the altitude of a triangle. The perpendicular line segment drawn from the vertex of a triangle to its opposite side is called an altitude of the triangle. Now in triangle ABC, here angle C is equals to 90 degree. We have AC is perpendicular to CB because the angle between AC and CB is 90 degree. And here the line segment AC is drawn from the vertex A to the side CB. So AC is an altitude of the triangle. Again, BC is perpendicular to CA because the angle between BC and CA is 90 degree, and the BC is drawn from the vertex B to the side CA. So BC is another altitude of the triangle. Again, C is perpendicular to AB. Here C is drawn perpendicular from the vertex C to the side AB. So C is the another altitude of the triangle. So from figure we have AC, BC and C, that is AC, BC and C are the three altitudes of the right triangle ABC. Also area of a triangle is given by half into base into altitude. So from figure area of a triangle right triangle ABC is equal to half base is BC into AC as the altitude, or we can write half into, if we consider AB as the base, then it is multiplied by the altitude CE. Now let us discuss about the Pythagoras theorem. According to the Pythagoras theorem, in a right angle triangle, the square of the hypotenuse equals to the sum of the square of its remaining two sides. Now look at this figure. Here triangle ABC is a right angle triangle with right angle at C, that is angle C is equals to 90 degree. Also from figure, the length of AB is taken as C, BC is taken as A, and CA is taken as B. So here AB is the hypotenuse of the right triangle because it is opposite to the right angle C. So AB is the hypotenuse, BC is the base, and CA is the perpendicular of the triangle. So by Pythagoras theorem, we have hypotenuse square is equal to base square plus perpendicular square. That is AB square is equal to BC square plus CA square. Or we can say C square is equal to A square plus B square. So hypotenuse square is equal to sum of the square of its two legs. Now let us verify the Pythagoras theorem by taking two different right triangles. Here already I have drawn two right triangles. The first right triangles with measurement 5 cm, 4 cm and 3 cm. That is triangle ABC. And the second right triangles PQR, that is with measurement 17 cm, 15 cm and 8 cm. You can take with your own choice of two different right triangles. After that, we will show all the measurement of these two right triangles on this table. The first column shows the measurement and length of the hypotenuse, the second base and the third perpendicular, after that hypotenuse square. Now, we know that square of a number is that number raised to the power 2. So, if x is a number, then square of x is written as x square, and is given by x square is equals to x is multiplied by x. So, square of a number is obtained when we multiply a number by itself. For example, here in this first case, the hypotenuse is 5 cm. So, that means to find out h is equal to 5 cm. So, that means h square is equals to 5 cm multiplied by 5 cm. We know 5 5s are 25. So, it will give 25 cm square, or we can write it as 5 square centimeter square also. So, here h square is coming here 25 centimeter square. Here already I have mentioned the units here. So, no need to write so it is not written here. Now, come to the next, base square. Here base square means 3. So, 3 square is 9. Perpendicular square, here perpendicular is 4. So, it is coming here 16, because 4 into 4 is 16. Now, after that we will find the sum of base square plus perpendicular square. So, this two sum, 9 plus 16, it is coming here 25. After that we will subtract this, we will find the difference between the hypotenuse square and the sum of this base square and perpendicular square. So, here already hypotenuse square is 25 and the sum of perpendicular square and base square is 25. So, after we will find the difference of them, it is coming here 0. Now, come to the next triangle. In the next triangle, the hypotenuse is here 17, because this is the side opposite to the right angle Q. So, it is 17. Base is here 8 centimeter. Then perpendicular is here 15 centimeter. Now, again, what is the value of hypotenuse square? That means in this case, we have to find 17 into 17, h square. So, h is 17, then h square will be 17 multiplied by 17, which is after calculations, it is coming here 289. So, hypotenuse square is here 289 centimeter square. Then h square, that is base square, it is 64, and perpendicular square, that means 15 square, that is here 225. After that, we will find base square plus perpendicular square, that is 64 plus 225, which sum is coming here 289. Then we will find the difference between the hypotenuse square, this is the hypotenuse square, and the sum of perpendicular square and base square. So, their difference is coming here 0. So, from these two tables, we can see that here we can see that the difference in each of this hypotenuse square and the base square plus perpendicular square is 0. So, as hypotenuse square minus in bracket perpendicular square plus base square is coming 0. So, we can write h square is equals to b square plus p square. Here h denotes the hypotenuse, b denotes the base, and p denotes the perpendicular. So, which implies that hypotenuse square is equal to base square plus perpendicular square. So, which shows the Pythagoras theorem. Now, let's see the converse of Pythagoras theorem. If the square of one side of a triangle is equal to the sum of the squares of the other two sides, then the triangle is right angled, or we can say the triangle is right triangle. Thus, in a triangle ABC, if AB square is equal to BC square plus CA square, then the triangle is right angled at C. Why it is right angled at C? Because here the longest side is AB and its opposite angle is C. So, the triangle is right angled at C. Let's see one example. If the three sides of a triangle are given 6 cm, 8 cm and 10 cm, will they form a right triangle? Now, first we will find the sum of the squares of the two smallest side. Then we will find the square of the longest side. If they are equal, then the three sides will form a right triangle, otherwise not. So let us see. Here the two smallest sides are 6 cm and 8 cm. So first we will find the square of 6. So that is 6 multiplied by 6 is equals to 36. And 8 square is coming here. 8 multiplied by 8 is equal to 64. So here 6 square plus 8 square. That means sum of the squares of the two smallest side is equal to 36 plus 64. It is coming here 100. Now square of the longest side, that is 10 square. We are not considering here centimeter, only we are taking the numbers. So it is 10 multiplied by 10, which is 100. Now since 6 square plus 8 square is equals to 10 square. That means the sum of the squares of the two smallest side is equal to the square of the longest side, which shows that by converse of Pythagoras theorem that these three sides will form a right angle triangle. Now let's see one example. In triangle ABC, right angle at C, find the unknown x. Here the given figure, triangle ABC, where AB is given x centimeter, BC is given 3 centimeter and C is given 4 centimeter. So here the given triangle ABC is a right angle triangles with right angle at C. That means C is equal to 90 degree. So from figure, AB is the side opposite to the right angle. So AB is here the hypotenuse. So by Pythagoras theorem, we have AB square is equal to BC square plus CA square. Here the value of AB is x. We are not considering here centimeter. So x square is equal to BC means 3. So BC square means 3 square plus AC means 4. So 4 square. So x square is equal to 3 square means 9 and 4 square means 16. So 9 plus 16, which implies x square is equal to 25, which implies x square is equal to 5 square, which implies x square is minus 5 square is equal to 0. So we are getting an equation. Now in algebraic expressions, we have learned how to find the product of two binomials. So for example, a plus b multiplied by a minus b is equals to a square minus b square. So that means a square minus b square is equals to a plus b multiplied by a minus b. So here we will use this identity. So using the identity a square minus b square is equal to a plus b multiplied by a minus b, we have x square minus 5 square equal to 0. This implies x minus 5 multiplied by x plus 5 equal to 0. So product of two factor is equal to 0 means either x minus 5 equal to 0 or x plus 5 equals to 0. So which implies x equals to x minus 5 equal to 0 means x equal to 5 or x equal to minus 5. But that is x equals to plus minus 5 both. But here length x denotes the length of the triangle. So length cannot be negative. So we take x equal to plus 5. We will not consider here the negative sign. So the value of x will be only 5, not minus 5. So therefore AB is equal to 5 centimeter. Now alternatively, we can also find the value of x as x square is equals to 25. So this implies x is equals to plus minus under root 25. This is the symbol of square root. Now find square root is the inverse operations of finding the square. But as we are finding the value of x, that which denotes the length of the side of a triangle, so length cannot be negative. So here we will consider only the positive root. So this implies x is equals to root 25. So now onwards, when we will do this type of questions, we will only consider the plus root 25 because length cannot be negative. Since length cannot be negative, so x equal to under root 25. Now let's see, x is equals to root 25 is equal to 25 to the power 1 by 2. So we can also write here 5 square to the power 1 by 2, that is equals to 5 to the power 2 to, multiplied by 1 by 2. Since we have learned in exponent and power chapter that a to the power m whole to the power n is equals to a to the power m multiplied by n. So here we can write 5 to the power 2 multiplied by half, that is equals to 5 to the power 1. Therefore x is equals to 5. Now let's see how a minus b multiplied by a plus b is equal to a square minus b square is coming. Let us consider left hand side as a minus b multiplied by a plus b, and let a minus b is equal to x. Then left hand side is equal to a minus b multiplied by a plus b. So in place of a minus b we will put x. So this becomes x multiplied by a plus b, which is equal to x multiplied by a plus x multiplied by b. That is by distributive law of multiplications over addition. Now in place of x we will put a minus b. So a minus b multiplied by a plus a minus b multiplied by b. Now this is the binomial terms. This is the binomial and this is the monomial. So we will multiply the first term of the binomials with the monomial. That means this is by again distributive law. So a multiplied by a minus b multiplied by a plus a multiplied by b minus b multiplied by b. So a multiplied by a means we know a square, and minus ba plus ab minus b square, and ab is equals to ba because we know that product of two numbers always holds the commutative law. So therefore a square minus b square. Therefore we can say that a minus b multiplied by a plus b is equal to a square minus b square. So using this identity, that is a minus b into a plus b is equal to a square minus b square, or we can say a square minus b square is equal to a minus b into a plus b, we can solve many problems related with the Pythagoras theorem. So you will try the questions which is given in your book. I hope all of you understood the Pythagoras theorem and converts of Pythagoras theorem. So thank you all of you and have a nice day.